In this video, we're going to continue to talk about Maclaurin and Taylor series. We have 5 given functions, and Maclaurin series is given. And you know that you could come up with this series by going through the process of constructing Taylor series at x equals 0. Now, these 5 Maclaurin series are very useful, and you need to know this for the AP exam. You need to memorize these 5 Maclaurin series. Now, it could be overwhelming, but these two are very related, and these two are also very related. So, for example, instead of x, if you plug in negative x, you get 1 over 1 plus x. And here, just plug in negative x, and you'll get these values. Now, what is a derivative of sine of x? Derivative of sine of x is cosine x. What's the derivative of x? It's 1. What's the derivative of this term right here? You get negative x squared over 2 factorial, and so forth. So these two are very related, and these two are very related. Now we're going to find out why this Maclaurin series for this 5 function is so useful. Let's say you have f of x equals e to the 2x, and they want you to find the Maclaurin series at x equals 0. So what you need to do is you need to construct a Taylor polynomial at x equals 0. So I found the first derivative, second derivative, third derivative. And then I found f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. And I found out that e to the 2x will be like this. And when you clean it up, you get e to the 2x equals, you get 1 plus 2x plus 4 over 2 factorial x squared plus 8 over 3 factorial x cubed, and so forth. But there is a shorter way of doing this. Recall that e to the x, the Maclaurin series for e to the x is 1 plus x squared over 2 factorial and x to the n over n factorial, and so forth. By the way, this is called the general term. And all we need to do is, instead of x, to find the Maclaurin series. Now we're only talking about Maclaurin when x equals 0. In order to find e to the 2x, all you got to do is, instead of x, you got to substitute 2x. So e to the 2x, instead of x, you're going to just plug in 2x. So you'll get this. And when you clean this up, when you simplify, you will get 4x squared over 2 factorial plus 8x cubed over 3 factorial, and so forth. And notice, these two are exactly the same. But this one, the first method, took us more time than the second method. So let's say you want to build a Maclaurin series for this function. Now, note that you could use a shortcut when we build Maclaurin series. First, you need to realize that e to the x for Maclaurin series for e to the x is this series right here. Now we need to find e to the 2x. So all you got to do is, instead of x, you got to plug in 2x. Now we need to find e to the 2x minus 1. Well, since this is e to the 2x, when you subtract 1, this 1 goes away, so you're just left with these. Now we need to multiply this by 1 over 3. So in order to do that, we got to multiply this whole thing by 1 over 3. So when you do that, you get these terms right here. Now, let's simplify. And you get 2 over 3 times x plus 2 squared over 3 times 2 factorial times x squared and so forth. And for the general term, since quantity 2x to the n power is 2 to the power of n times x to the n, you get this for the general term. They're telling us to find the Maclaurin expression for f of x equals x times sine of 2x. So in order to do that, we first need to realize that sine of x is, the Maclaurin series for sine of x is this. Now we got to find sine of 2x. So in order to do that, instead of x, we need to substitute 2x. And when you do that, you get this expression right here. Now all you got to do is multiply sine of 2x by x. So x times sine of 2x is x times this whole expression right here. And when you distribute the x to each term, you will get 2x squared minus 2 to the third over 3 factorial times x to the 4, because this is x to the third, but you're distributing the x. So this becomes x to the 4. So that, and you get the rest of the terms. And this is the Maclaurin expression for x sine of 2x. Now they want us to find the first 3 terms of the Maclaurin expansion for f of x equals e to the x times cosine x. So in order to multiply e to the x and cosine x, you need to first realize that e to the x is 1 plus x squared over 2 factorial and so forth. And cosine of x for Maclaurin series is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial and so forth. So when you're multiplying e to the x times cosine x, that's the same thing as multiplying this expression times this expression right here. So we need to multiply this out. So when you distribute, this is the same thing as 1 times this expression plus x times this expression plus x squared over 2 factorial times this expression. And it is a good thing that we only need to find the first 3 terms. Otherwise, we have to keep going, and it's going to be very tedious. Now, to be safe, what we're going to do is we're going to multiply x cubed over 3 factorial to this expression. Now, let's distribute. Let's multiply out and combine the like terms. So after you distribute, you get these terms. And then we need to add up the like terms. So when you look at this expression, you only have 1 as a constant, and you only have 1x. Now let's take a look at x squared. You got negative x squared over 2 factorial and positive x squared over 2 factorial. So what I'm going to do is I'm just going to put the coefficients and put x squared plus, and look at the x cubed. You got negative 1 over 2 factorial and positive 1 over 3 factorial. And that's good enough because they just want the first 3 terms. So this cancels out. So you get 0 for this. You get 1 plus x. And what about that one? This is negative 1 over 2 plus 1 over 6. So this is the same thing as negative 3 over 6. So negative 2 over 6, which is negative 1 over 3 x cubed. And of course, this goes on and on and on. But we found the first three terms, so that's good enough for e to the x times cosine of x.